Okay, so continuing on with our linear functions, we're going to talk about a couple more ways that we could write an equation of a line today. So here are the three ways that we could write the equation of the line. Over here in purple, you'll see our normal y equals mx plus b, which we call the slope-intercept form. Down here in green, we have the point-slope form. One thing about the point-slope form I would like to see you guys do is to put parentheses around this y minus y1. And when you have a y sub 1 and an x sub 1, that basically is telling you that we're going to replace those with numbers. And the m, of course, is going to get replaced with the number, but the y and the x are going to stay there. And then our last one is the standard form. We do a lot of things in standard form this year, anywhere from lines to quadratics to circles. We're going to talk about the standard form of a lot of things. So these are the three ways. We're not really going to talk about slope-intercept too much because we've already done that in the last section, but the other two we're going to talk about. The point-slope form is a real easy way to write an equation of a line because there's not a lot of work to do, especially if you're given the slope right off the bat like we have in this problem. I'm telling you that the m is 3 over 5. So we know where that goes. It goes where the m goes. And I'm also telling you that x is negative 5 and y is 2. Now, this year we're going to do a lot of stuff with parentheses, meaning putting numbers into parentheses, taking them out. And I'm going to tell you right now, if we can get this idea down, it's going to make life a lot easier. When I put a number into a parenthesis or take it out of a parenthesis, if it's a term alone, then I just change its sign. So I'm going to put the negative 5 into the parenthesis with the x. I'm going to put the 2 into the parenthesis with the y in the places of x1 and y1. And all I have to do is change their sign. So when we take the 2 from the ordered pair, the y value, and put it where y1 goes, you see that it went from a positive 2 in the ordered pair to a minus 2 in the parentheses. And the 5, the negative 5 in the ordered pair, went to positive 5 when I put it in the parentheses. And it's that easy. And we don't have to distribute, we don't have to do anything else. This is point-slope form. With a little bit of algebraic magic, we could actually turn this into slope-intercept form. I would just have to solve for y. Solving means get rid of parentheses, combine like terms, get the y by itself, and we'd be in y-intercept form. So here we have 2 points, and I want the line that goes through these 2 points, and I want you to give it to me in point-slope form. Remember, the most important thing about a line is its slope. We have to find the slope first, and there's only 3 ways to get the slope. I give it to you, I give you 2 points, or I give you a different line and we steal their slope, but that's going to come up in a little bit. All right, so go ahead and stop the video and see if you can do this one on your own. Okay, so here we go. I'm going to do the slope formula, which is y2 minus y1. So I got 8 minus 2 over 5 minus 3, which will give me 6 over 2, which gives me 3. So I'm going to go parentheses y minus y1 equals 3 parentheses x minus x1. Now if you look up there, I have 2 different points that I could choose from. It does not matter which one you choose. It'll be the same problem. So we could do y minus 2 and x minus 3, or we could have done y minus 8 and x minus 5. These are the same problems, because if you think about this, if I distribute here and distribute here, that's going to give me a negative 9 right here, right? And I have to move this negative 2 over. By adding, I would end up with a negative 7 for my b. If I distribute the 3 here, I get negative 15, and when I move this 8 over by adding, negative 15 and positive 8, they both make negative 7. So we would get the same answer either way. So it doesn't matter which point you choose after you find the slope. All right, and moving on to our last equation form, and that is the standard form of a linear equation. That is written here, capital AX plus capital BY equals capital C. There are 3 rules that you have to abide by. Rule number 1, no fractions. And I'd also say no decimals, but a decimal is just a fraction, so no fractions should take care of that. The second one is x and y on the same side. So they have to be on the same side. And 3, this is kind of a personal preference. X has to be positive. If you follow all those rules, you'll have it in standard form. So here we have an equation that's in slope-intercept form, but I want to write it in standard form. So I got to go through my rules and see if I've broken any of the rules. The first rule is no fractions, and obviously I broke that. Now remember, we can get rid of fractions if we multiply every single term, not both sides, because if you want to multiply both sides, you have to have one term on both sides, so we'd have to put parentheses. But I'm going to multiply every single term by the common denominator, which in this case is just a little 4. So I'm going to put a 4 next to everything, and that's going to give, I'm going to actually cross out the denominators. That's going to give me a 4y, a 3x, and minus 4 times 5, which we can simplify that a little bit. 4y equals 3x minus 20. So I fixed the rule 1 that was broken. Rule 2 is x and y have to be on the same side. Well, that's broken also, so I have to fix that. So I'm going to move the 3x over to that side by changing its sign. All right, so we got that. Well, by fixing rule 2, I just broke rule 3, which is x should be positive. So the way to fix this is just to divide every term by -1. Or you could multiply every term by -1 if you'd like. Doesn't matter. All right? And I get 3x minus 4y equals positive 20. These two equations are the same line, just written in different forms. So this year you're going to be asked quite a bit about x and y intercepts, so we might as well start off talking about them early in the year. So when you find x and y intercepts, really all you're doing is substituting in a 0, because anytime there's a 0 in an ordered pair, it's going to be one of the intercepts, and you solve for the other variable. So if I want the y intercept, I'm going to put a 0 in for x and just do the math. If I want the x intercept, I'm going to put a 0 in for y and do the math. And we always give our intercepts as a point. So when I put a 0 in for x, I got out of 3. That's the y-intercept. When I put in a 0 for y, I got out of 5, and there's the x-intercept. And since those are intercepts, those are also considered points. If you graph them on a line, on a coordinate plane, you can create a line because you only need 2 points to make a line. So let's move on to the very last way to get a slope. Remember, there's 3 ways to get the slope. I give it to you where I say, hey, m equals 3, or the slope is -1/2. Or I give you 2 points where you have to do the slope formula, y2 minus y1 over x2 minus x1. The last way is I give you a line, and we steal its slope, and we also say, hey, this new line that we're going to make is either parallel to the old line or perpendicular to the old line. You got to remember from the last couple of years what parallel means. Parallel means we have the same slope but different y-intercepts. The same slope is obvious because they have to, look the same. Different y-intercepts, because if it was the same y-intercept and the same slope, we'd have the same line, and therefore you wouldn't have 2 lines being parallel, you just have 1 line, all right? And then perpendicular, the slope has to be negative reciprocals to each other. Negative reciprocals means you have to do 2 things to the slope. You have to flip the sign and flip the fraction. Flipping the sign is the negative part. You're changing the sign. Flipping the fraction is the reciprocal part. So if you do both of them, you've created a negative reciprocal. So let's do an example. This is how I want you guys to do this, all right? So whenever I give you a question and it says, hey, what is the equation of this new line that's parallel to this old line, I want you to go old, slope, and new slope, right? If the line is written in y equals mx plus b, then it's pretty easy to figure out the slope. In this case, it's 6. If it's not written in y equals mx plus b, I would suggest solving for y to figure out what the slope is. So this said parallel, right? Well, parallel is the same slope, so I need to put the 6 over here. So we have our slope. I know that it's going to look like this. When I'm done, it's going to be y equals 6x, and then I'm going to fill in the rest of it over here, all right? The only way to get the b, there's two ways. I can give it to you, or you use a point that's given and do some algebra, all right? So I want to show you with point slope form how easy this is. So I'm going to go back to point slope form where I put this in here. I know the m is 6, put the x here, and I'm going to put these two numbers in. The y is -3, so I change its sign and put +3. The x is +1, so I change its sign, put -1. And now to get from here to here, all I have to do is solve for y. So I got to get rid of the parentheses through distribution. So distribute a 1 and distribute a 6. And then get the y by itself by subtracting 3 from both sides. And I get y equals 6x minus 9. And there's the line that is parallel to 6x minus 2, but goes through the point 1 minus 3. And our last example is a perpendicular. This tends to be the one that most kids really struggle with. But if we do it the same way, we write down old slope and new slope. That'll get us halfway there, all right? So we look at this and say, okay, is that in y equals mx plus b? We say yes, so we write down -4. And then we look at the word that they're using. It's perpendicular. Well, perpendicular is different than parallel, and since parallel was the same slope, perpendicular has to be different. And remember, it's a negative reciprocal. You have to do two things. You have to change the sign, so it becomes +4, and then flip the fraction. That's 4/1, so when I flip it, it becomes +1/4. When I'm done, I want it to look like this, 1/4 x, and I got to fill this in with the b. Let's go back over here and do y minus, or the point slope form. All right, fill in all these. There's my point. I'm going to take the 5, change its sign, put it in with the y. Take the 8, change its sign, put it in the y. Distribute so I can solve for y. That comes 1/4 x. 1/4 times -8 is -2. My last step is to add the 5 to both sides, and I get y equals 1/4 x plus 3. And there's the line that is perpendicular to our line up here and goes through 8, 5. And that completes today's lesson.